Since I joined, obviously we tried to, emphasize a lot more on like the importance of interdisciplinary research within quantum. And we brought together a lot of faculty members and we tried to talk to them and try to use their skills and put them toward, the quantum problems that we have these days. So my name is Kasper Sardashti. I am an assistant professor of physics and astronomy, as well as electrical and computer engineering at Clemson University in Clemson, South Carolina.
My name is Junior Langa. I go to school at Clemson University. I am right now a grad student in my third year. I'm studying physics.
I mostly focus on quantum hardware research, specifically on mitigating the defects in materials and improving the quality of solid-state quantum hardware.
I've always been interested in technology, more specifically computers. And when I had the opportunity, when Kaz invited me over, I thought, this is definitely where I want to be. I definitely want to make an impact in this field. I want to have a say in quantum computers and making them more tangible.
We are obviously working on quantum hardware, so our focus is really on the bottlenecks of scaling quantum computers, more specifically superconducting quantum systems, with two approaches. One of them is focusing on mitigating defects, basically making the error levels lower. Part of this coming from the coherence of the systems. Basically, quantum systems are very fragile and they're very, very sensitive to tiniest energy fluctuations in the systems. So we are trying to look at materials that host less fluctuations, less error, and less defects.
We use superconductors. We make thin films from them, and we integrate those with semiconductors like silicon or germanium.
Another approach that we're taking is to focus on the scalability of these systems with an eye on tunability. Tunable qubits are an idea that has been out there for a long time. So we're looking at integrating semiconductors into superconducting circuits and creating voltage tunable quantum devices, which seems to be a simple problem, but it's not really a simple problem because you actually have to bring semiconductor and the semiconductor materials knowledge into the superconducting world. And because you have disparate materials with disparate properties, there's gonna be a lot of material challenges that you have to address.
That's one of the, issues right now. We definitely want more people to work on these problems because they're challenging problems, but they're rewarding. So I think quantum computers can definitely help people. It has lots of applications, encryption with the medical system, finding new drugs.
Since I joined, obviously we tried to, emphasize a lot more on like the importance of interdisciplinary research within quantum. And we brought together a lot of faculty members and we tried to talk to them and try to use their skills and put them toward the quantum problems that we have these days. And a lot of these things are, microwave engineering, photonics engineering. They're not new things. In a lot of fields, people are already working on them, or sometimes occasionally they even solve the problem. So it's really interesting to bring the solutions from other fields into quantum and be like, oh wow, like we didn't know about this. This solution was there all around.
There's lots of fields that are involved in quantum. More specifically, we have the chemists, we have material scientists, there are electrical engineers also involved, physicists. And yeah, I think we need a big field of people devoted to this problem, and that requires a lot of collaboration.
At Clemson University, we've been working a lot on, developing new internship programs and training programs for specifically our undergraduate students. Even, the conferences that we organize, a lot of them will be the emphasis of getting the undergraduate students into the room, getting them familiar with what's going on out there. These are all these cool things that nobody's, aware of.
I know we have some collaborators in Winston-Salem that are starting quantum programs and are getting fridges, illusion units, and hopefully that can increase interest.
In the US, a significant issue, especially in the STEM fields, lack of diversity is a major issue. Quantum is not, an exception. So we've been working with another university called Winston-Salem State University to launch quantum workforce development programs. They have been able, through our help, to secure major funding from Department of Energy and National Science Foundation to actually launch a bachelor degree program in quantum information science. And they're also building infrastructure to train the students. And they're gonna be very well trained to either go to the workforce directly or, go to graduate school and after that join the quantum workforce and, help us push this forward. Because without people, we can't really achieve the goals that we would hope to achieve.